Hey guys, it's Mathematics YT. Today we are going to prove the volume of a cone, or we call as V, is equal to 1 over 3 pi r square h. Now in this video, I will talking about how are we going to find the volume of a cone in visual proof, and how the solid of revolution formula come out, and I'm actually solving the volume of cone using the formula of solid of revolution. So let's get started. Let's start how to prove the volume of a cone using, I call it visual proof, because you can find the results by using your hands and your eye. So here's the procedure of proving the volume of a cone. Now you make a cone and a cylinder with the same length of radius and height, and make sure inside of it is hollow. You can make the cone and the cylinder. You can 3D print if you have money to buy that machine. But if you manage to make a cone and a cylinder and they are hollow, then we can go into the second step, which is we need to fill the cone with water and pour it to the hollow cylinder, and then you repeat step 2 until the cylinder is filled. Then the observation that you have obtained is by doing step 2 for 3 times. So we do it repeatedly, and then we notice that the cylinder is filled. Now we know that the volume of cylinder is equal to pi r square h. So what can I conclude is 3 times the volume of a cone is equal to pi r square h, because water is filled. We're talking about finding the volume by using water. But when it's filled all the water inside, then it means the volume of the cylinder. So by pouring the water cone that is filled with water to the cylinder for 3 times, then you can get a cylinder that is filled with water. So if you do this for 3 times, then you get this. So the volume of a cone is equal to 1 over 3 pi r square h. Now let's talk about how can we find the solid of revolution. Now how do we can find the formula to find the solid of revolution? Now let's say we take part of a whole solid, the whole geometric solid. We take part of them, and the length of here I will call it as delta x. If I take a part, then it means I will take part of the whole volume, which I call it as delta v. This whole thing is equal to delta v. So the delta v is equal to this geometric solid. Now if we look carefully, this solid looks like a cylinder. So we take a part of volume, then we need to find the volume of this partial solid that we take from here. So delta v is equal to pi times the y, because y is a radius, pi y square times delta x. And to find the volume, now we know that delta x is okay, so we know that if we take part of this delta v, and we have the volume of this partial cylinder, like the partial geometric solid that looks like a cylinder. So how are we going to find the volume? Now, the delta V, it can be equal to dV, because we just take the part of the solid and the delta V, it can be equal to dV if it's about the small approximation. Then the delta X, I can call it as Tx. If let me just write down this. So dV is approximately equal to delta V. Then if this is the small approximation for these two equations, and then we are going to integrate. So V is equal to, but wait, we cannot just simply integrate like this, because if integrate like indefinite integral, then we can get the function. The result is a function, but the problem is I want to have a number, because we talk about volume. Volume is when we talk about volume is when we talk about number, not like with unknowns, if not something like that. So the integral of pi y squared dx is converges at the first place. So the volume of a solid of revolution is equal to the integral of pi y squared dx. But wait, the geometric solid rotates from point A to point B, so the integral of pi y squared dx is from x is equal to the integral from A to B. So let's start prove the volume of a cone using the solid of revolution. Now I just told you guys that since the cone has a flat circular surface at the bottom, then it has a higher, that is the possibility that the cone is actually one of the solid of revolution. Now I have everything visualized as here. So this is a cone. If I undo the 360 degree, we will get a straight line, and of course it is intersect with origin. Now for the equation of a straight line, we know that the general form of it is y is equal to mx plus c, where m is the gradient and the c is y-intercept. But if the line is intersects at it, the line is drawing across origin, what will the c equal to? It is equal to 0. So we just need to find the gradient. So what is the gradient of this equation of straight line? Now I have r here, I have h here. So r will be the vertical distance of this equation of straight line, and the h will be horizontal distance. So we know that the gradient is equal to vertical divided by horizontal. So the function y is equal to r over hx plus c, where the c is equal to 0, so we no need to write it down. So we know that y is equal to r over hx. Then we can rotate 360 degree on this function. So I will get integral of, so the volume is equal to integral of pi times r over hx bracket square dx from where? Now if we're talking about integrating the variable x, then the limit, the upper and lower limit must be talking about x. Now this is the point of x right here and right here. So we are integrating the variable x. So the lower limit, so the limit of the x is 0 and h, where h is bigger than 0, because in a geometric solid the measurement must be positive. If it's negative, then it does not make any sense. So h is bigger than 0, so h must be at the upper limit and 0 must be the lower limit. So this is the volume of a cone. Now okay, we will expand this expression. So v is equal to pi times h over 0 times v is equal to integral of pi times r square over h square x square dx from 0 to h, and then I call this thing outside here. So v is equal to pi times r square over h square times integral of x square dx from 0 to h. So v is equal to pi r square times x cubed over 3 from h is from 0 to h. Then we plug in h here. So v is equal to pi r square times h cubed over 3 minus 0 cubed over 3. 0 cubed over 3 is still equal to 0. So v is equal to pi r square over h square over h square over h square times h cubed over 3. And this simplify, then this simplify. So v is equal to 1 over 3 pi r square h. And we have proved that the volume of a solid is equal to this by using the solid of revolution. Let's start proving the solid of revolution that is rotate about y-axis. Now the formula that we did just now is the formula of the solid of revolution when the line rotate about x-axis. But what about y-axis? Now when we want to integrate, or when we want to find the value of the area from the point y, which is start from here. Now if we want to find the lower limits for x, it should be start from here to here, but for y it's quite different, because when you want to integrate y, you need, for definite integral, when you want to integrate y, you need to find the lower and upper limits for y. So it basically start from somewhere at the y-axis, at the y reading. So it basically, the curve or the shape that we obtain is quite different, so the area might also be different. Now we have y is equal to f of x, x is bigger than or equal to 0, and then I have draw a cylinder right here, and the length of here is delta y, and this whole volume is partial solid right here. So this is I will tell it as delta v. Now I took this whole thing to here now. So the volume of this partial solid, I will say delta v is equal to pi x square. This is x. This length start from here to here is x. But how to find x? Now logically, okay, we have a function y is equal to f of x, where the y is the title of the function, and the function is expressed in terms of x. So to integrate y, we have to express x as subject formula. So delta v is equal to pi x squared times delta y. Now, but wait, this solid is just looks as similar to the right solid. So basically it's just a small change from this solid. So I can conclude that this volume, or the volume of this partial solid, is almost equal to this volume of right cylinder. So I will write as delta v is approximately equal to dv is equal to pi x squared. Then this delta y is also a small change from the y cylinder from this cylinder. So I can conclude that the height of this cylinder can be equal to dy. Then we can integrate, but since this volume it converges at the first place, so v is equal to let's say from point A to point B, which is equal to integral of pi x squared dy from A to B. So that's probably how you're going to find the solid of revolution that is rotate from rotate about y axis. Okay, this is how it looks when the cone is rotate about y axis, and when we undo the 360 degrees we will still get a straight line. So we need to find the equation of this straight line. So how are we gonna do that? Now we have from 0, we start from 0 to r. This is actually x-intercept, and from here to h is actually y-intercept. So the gradient is equal to negative y-intercept over x-intercept. So m is equal to negative h over r. So y is equal to negative h over r x plus the y-intercept h, because this line is not intersect across the origin. So now we have found the function y. So the next step we are going to do is express x as subject formula, because when the line rotate to y-axis, we need to integrate the solid in terms of y. So let's do it. So y is equal to negative h over r x plus h. Y minus h is equal to negative h over r x. So x is equal to r over h times h minus y. When we find the function that is in terms of y, then we can finally find the volume of it by using the formula. So v is equal to integral of pi times r over h times h minus y bracket another bracket square dy from y is equal to 0 to h. Then we expand this expression. V is equal to integral of pi times r square over h square times h minus y bracket square dy from 0 to h. V is equal to integral of r square over h square pi times h minus y bracket square dy from 0 to h. Then v is equal to r square over h square pi times the integral of h minus y bracket square dy from 0 to h. Now here's the part that is really interesting. Now, can we expand this expression? Yes, you can. When after expand it, then you can basically just solve the integral, and eventually we can get the volume. But we don't want that. We want shortcut. We really want shortcut. So what is the shortcut now? Inside this function, I call it function h minus y, we need to integrate y, so we need to concentrate on this. Now here's y with power of 1, but and the outside has no y. So I can conclude that the derivative of y is equal to 1, which will make that when I multiply it with 1, then we have no other y terms. So this situation is very familiar. When you see something like this where y is in the power of 1 and the outside of it has no y terms, or I could say the y with power of n is inside the function and the outside of it is y power of n minus 1. Now when you see something that is related to this, I can use something called u substitution. So I want to substitute this whole term. So u is equal to h minus y. Then we differentiate both sides. So du is equal to negative dy. Then dy is equal to negative du. So we substitute to here, and this becomes u. So v is equal to the integral of, actually not integral, so r squared over h squared pi times the integral of u squared times negative 1, so negative u squared du, and I want to find the limits for u. So how do we going to do that? Now we know that this is y is equal to 0 and this is y equal to h. So we just substitute this term, but we must do it in order. Example, if I have the limit, if I have the upper limit h and I substitute here, so u is equal to h minus h, which is 0. So the upper limit for u is 0. And the lower limit for u is, substitute y is equal to 0, so h. And now, the next thing I'm going to do is, I'm going to cancel down this negative, but actually flip the limit upside down. And don't forget, this is in terms of u. These two limits are in terms of u. So v is equal to r squared over h squared pi times the integral of u squared du from 0 to h, and then we solve the integral. So v is equal to r squared over h squared pi times u cubed over 3 from h is equal to 0. So v is equal to r squared over h squared pi times h cubed over 3 minus 0 cubed over 3. So v is equal to the integral of, not integral anymore, r squared over h squared pi. So 0 cubed over 3 is 0, so this thing minus this minus 0, we still can get the same term. So h cubed over 3, and this thing simplify. So v is equal to 1 over 3 pi r squared h, and then we have found the volume of the cone that is also rotate about y-axis. This is a huge success. I will see you guys next time in the another video.